Hey, 30-1s. So what we're going to do in this lesson is we're going to look at stretching functions. So what that means is we're going to basically be kind of, instead of moving the graphs left and right, we're going to start kind of pulling on them up and down and left and right. So we're going to stretch them vertically and stretch them horizontally. Okay, let's see what this means for us. Okay, again, what I'm going to do is let's always start with something we know, and we know parabolas pretty well. So let's look at this parabola. We're going to find the intercepts of y is equal to x squared minus 6x plus 8. Okay, so what we're going to do is to find the x-intercepts, of course, first thing we'll do is we'll factor, and we'll set it equal to 0. And then we'll use the zero product property. So we know our x-intercepts are at 4, 0, and 2, 0. Okay, so our factored form. Now, up here in our standard form, what's nice is the constant term, remember, gives us that y-intercept. So we've got a y-intercept at 0, 8. Okay, so there's the intercepts. Now what? Okay. He says, what happens if we replace y with 1/2 y? Okay, strange thing to ask, but let's go and do it. Let's see why. Okay, so it says replace y with 1/2 y. Okay, can do. Now, how is that replacement going to affect our graph? Well, let's find out. I'm not used to seeing things as 1/2 y. I like just y. So let's multiply both sides by 2. And what that'll do is that'll get y isolated like I'm used to. Okay, so there's our equation in standard form. Okay, what about if we did this in our factored form? So again, replace y with 1/2 y. Multiply both sides by 2, right, to maintain that equality. There it is. Okay, now let's say to ourselves, how did that affect our intercepts? Well, in standard form, that's our y-intercept. So our y-intercept is now 0, 16. So our y-intercept transformed from 0, 8 to 0, 16. Okay, what about our x-intercepts? Well, our x-intercepts, again, we always let y equal 0 and solve for x. Well, guess what? We still get 4, 0 and 2, 0. Do you notice those are the same x-intercepts? Okay, so what just happened here? Well, when we replaced y with 1/2 y, the only thing that changed was our y-intercepts, or what I want you to think about in more general terms is the y values. And what happened to our x values? They stayed the same. So when we replaced y with 1/2 y, what did we really do? We just vertically stretched. So vertically, again, I want you thinking is your y values. We just vertically stretched by 2. That's what we just did. We just multiplied all the y values by 2. Okay, what about the x values? Well, the x values didn't change. So there's a really important term here I need you to know for something that doesn't change. These were known as invariant points. So vary means to change. So invariant means not to change. So what did we do? Replace y with 1/2 y, which means we ended up vertically stretching by 2. Okay, let's see if we can try this again. See what happens. So what happens if we replace x with 1/3 x? Okay, so let's go for it. So we go and replace x, and let's do our factored form first here. Okay, like that, and right here, like that. Okay, and okay, what's our new x-intercepts? Well, our x-intercepts here, I'm gonna have to do a little bit more work on this one, right? So we set them both equal to 0. We use that zero product property. Okay, and when we solve for x here, we're gonna get 12. So one x-intercept's now at 12, and the other x-intercept is going to be at 6. Okay, so wait a minute. Now our x-intercepts have changed. Okay, let's look at standard form, and we'll look at our y-intercept. So if we do this thing in standard form, so all we're just going to do here is I'm just going to distribute out, multiply these two binomial factors together. What are we going to get? Minus 2/3 x minus 4/3 x, and most importantly is that plus 8 right there. Our y-intercept, the constant term is that y-intercept, it's at 0.8. So do you notice our y-intercept hasn't changed? So that's our invariant, or it's a invariant point. What about our x-intercepts? Well, our x-intercepts went from 4,0 to 12,0 and from 2,0 to 6,0. So guess what we just did? We just horizontally stretched by a factor of not 1/3, but by 3. So we horizontally stretched by 3. A factor of 3, some people would say. Okay, so I'm hoping you're already starting to pick up on a bit of a pattern between what I'm replacing with and what I'm actually stretching with. Okay, let's keep building on this, and we'll get a little bit more formal each time. All right, what do we have here? If the function y is equal to f at x is transformed by a horizontal stretch of 3, and you notice here I've typed about the y-axis. We are always going to describe the axis we're stretching about. So we'll say about the y-axis, and the vertical stretch, well, vertical would be about the x-axis in the middle. It says write the equation and the mapping rule. Okay, so what this means, if I'm going to horizontally stretch by 3, what I want you to notice, what we did in the last question, was we then replaced x with 1/3 x. And if I want to vertically stretch by 2, like we did in the last question, I'm going to replace y with 1/2 y. So I think of my replacements, and then I go and I start to make my new equation. So there it is. Now notice it's an f. It's some function. I don't know what it is. Is it a parabola? Is it a cubic? Is it an absolute value? I don't know. Now, most of us are used to having y isolated. So I'm going to multiply both sides by 2. And there it is. There would be the equation of your transformed function. Okay, what's our mapping rule? Okay, I'll do map in hot pink. We don't have enough hot pink in our lives. Well, our map, again, you're doing as you're told. So if I'm going to horizontally stretch by 3, I'm going to multiply the x values by 3. And if I vertically stretch by 2, I'm going to multiply the y values by 2. So notice again the difference between your map and your actual equation of the function. They're different things. Okay, so where did we go? We started by thinking of replacements. Then we made the equation of our function, and we made our map. All right, let's try another one. There's not a heck of a lot to places where, you can get, if I want to say the word tricked, right? Where people are going to get fooled is maybe in here in the 1/4. So the graph of y is equal to f at x is transformed to become 2y equals f 1/4 x. Describe the transformations. Okay, the first thing I like to do is I like to isolate for y. Okay, myself. Okay, that's not a bad idea to do. And when I said do that, then I forgot the 2. If you want to think of this in terms of replacements, what's happened? Y has been replaced with 2y. X has been replaced with 1/4 x. So what are our transformations? Again, no abbreviations. Let's start with the y. Vertical stretch. And now here comes the most important part. I'm hoping you're noticing it's by the reciprocal. A vertical stretch by Just notice I wrote my equation wrong up there, friends. Sorry, not enough coffee. Coffee in me. A vertical stretch by 1/2, and this is the important part now, about the x-axis. Or you could say the line y is equal to 0. Those two things mean the same. What else did we do? Well, we horizontally stretched by, again, the reciprocal, by a factor of 4 about the y-axis. Or if you wanted to call that the line, x is equal to 0. Okay, so there it is. So with stretches, the key to the stretches is when you're doing the replacements, you want to think you're stretching by the reciprocal. Okay, now notice up here when I said I like to isolate for y. So you notice here the 1/2. Well, once I've isolated for y like that, that matches my stretch there. Okay, so there's two kind of different ways to do that or to think of that. Okay, so let's wrap this all up. What have we got? If we have transformed a function and we've got the a and the b, what do we have? The a value is our vertical stretch. So this is our vertical stretch. And again, when we're vertically stretching, it's about the x-axis, or y is equal to 0. And when you're vertically stretching, what you're doing is you're multiplying the y values. What about the b value? Okay, so the b value is our horizontal stretch. So what that means is it's about the y-axis, or x is equal to 0, and you're multiplying the x values. But what are we multiplying for both of these stretches? What are we multiplying the x and the y values by? So for the vertical stretch, in the way it's written right here, I would be multiplying the y values by a factor of a. So what would happen here is our map, xy, would become xay. For the way it's written up here for the horizontal, what we're doing is we're multiplying the x values by a factor of 1 over b, the reciprocal. So our map would become xy, comma, 1 over b times x, comma, y. There it is. Now, the one last thing that you really want to be thinking about here is what about invariant points? Invariant points are points that don't move, okay? So invariant points are points that don't move. Invariant points for stretches will fall on the axis you're stretching about. The reason why is if you're vertically stretching, so let's just draw a nice parabola like this. Like we saw earlier with the very first question we did, if I vertically stretch this thing, that means I'm multiplying the y values. Well, my x-intercepts have a y value of 0. So if I'm vertically stretching, those aren't going to change. So my invariant points for a vertical stretch are on the x-axis. And if I was horizontally stretching, that means I'm multiplying the x values. Well, my y-intercept has an x value of 0, so it won't change. So again, your invariant points will fall on the axis you're stretching about. Well, guess what? You have to describe that in every question. So as soon as you say it out loud, that's the line I'm stretching about. That's where you'll look for your invariant points. Okay, friends, go and play around with stretches. What we're going to do, we've got one more lesson to do. And all we're going to do in the last lesson, or the last new thing we've got to learn, is what happens if A and B are negative. Okay, so what happens if A and B are negative? Okay, I'll see you later.